Welcome to Technology Today for July 28th, 2024. It's Season 1, Episode 23. I am Mayor Watt, and that is the Technology Today channel over at ohmTown.com. I'm streaming here to Twitch and YouTube simultaneously, and the Sentient AI isn't available today. They're off doing an assignment that takes all of their computational power. So the Sentient AI will return probably next week. So with that said, what we're going to be talking about, you know what? Everything's powered by ohmTown.com, so go over and check it out. There you go. We have an intro. It's been around for a little while. So at any rate, we're going to be talking about why we exist, explained, cheese of the future, redefining consciousness, AI detecting cancer at lightning speed, NASA uses AI with perseverance, redefining time and space, taco technology today, the heaviest element, can a tornado be stopped, and zero emission recipes. Let's just jump right on into this. Okay. So just a little word of warning. Things are weird because my primary monitor failed yesterday, and I haven't been able to get it replaced in time for the shows. It won't be for a little while as well. And all next week, I'm going to be tied up, so I won't be able to do any of the shows, and next week's weekend shows might be late. We'll probably end up doing them on Sunday, but just the daily shows and the weekly shows may not make it out in time, as Mayor Watt is doing mayoral duties. Yeah. So with that in mind, let's get into today's articles. And the very first one is over in Technology Today. Physicists just made a breakthrough that could explain why we exist. Researchers have successfully measured the quantum structure of radium monofluoride using ion trapping and specialized laser techniques, allowing for the detailed characterization. Of what, though? So the U.S. Department of Energy put this article together. It's published at scitechdaily.com. And so it's allowing for the detailed characterization of its rotational energy levels and establishing a laser cooling scheme. The findings are crucial for the future experiments focused on laser cooling and trapping RAF molecules, which are expected to play a significant role in studies of nuclear electroweak properties and violations of parity and time reversal symmetry, potentially explaining the universe's matter-antimatter asymmetry. Got all that? There's a test. Anyway, there's a weird thing about light, by the way, that apparently it has the ability to reverse itself and redirect where it's supposed to go in the time slit experiment. I watched a couple of things about it a long time ago, and I need to go back, but that time reversal symmetry thing is kind of interesting to me. Because I'm really fascinated by time and time travel, the science and science fiction of it. So I even created a channel here in ohmTown called Temporology. Dunk. Yeah. Anyway, so for the first time, nuclear physicists have made precision measurements of a short-lived radioactive molecule, radium monofluoride, or RAF. Now, the researchers combined ion trapping techniques with a specialized laser system to measure the fine details of the quantum structure of RAF. This allowed the characterization of the rotational energy levels of the molecule, as well as the determination of its laser cooling scheme. Something that I use as the mechanism for time travel when I am writing something, or trying to discuss like science fiction style world building, is in my time travel omnibus. The only way to do time travel is to change your quantum signature so that you can calculate what your quantum decay is and then use technology to reverse it, and you take over your own body, but in the quantum state of the past or future after predicting it. So nothing violates the real nature. You can't get a paradox, because you are you no matter what. Even if you do events, you have to align going back to the future. So you can't get hit by a bus because you're doing something stupid when you're in the past. Essentially, the universe doesn't allow you to make that kind of a decision, to harm yourself. And you know that it's going to happen because your quantum signature is traversing the entirety of your existence through time and space. There's a lot more to it, but anyway. So laser cooling is a method that uses laser light to slow down and trap atoms and molecules, and these results represent a pivotal step for future experiments aiming to laser cool and trap RAF molecules. So they have the ability to measure these RAF molecules. Scientists predicted that the molecules that contain heavy pear-shaped nuclei, such as radium, are highly sensitive to nuclear electroweak properties and physics beyond the standard model. This includes phenomena that violate parity and time reversal symmetry. Time reversal violation beyond the current constraints is an essential condition to explain the matter-antimatter asymmetry of the universe. The new results give researchers a detailed characterization of the quantum structure of RAF, opening the use of this molecule in future experiments aiming to search for such effects. So because we know of one, it can reduce the variability of discovering the same structures, organizations, manners of energy transfer or whatever in others. So it'll be quite interesting to see where this goes. The researchers' method allowed the mapping with high sensitivity of the RAF energy levels, determining a laser cooling scheme for slowing and trapping the molecule, and scientists are rapidly developing methods of controlling and interrogating ultra-cold molecules. These methods, combined with new capabilities of radioactive beam facilities to produce large amounts of radioactive molecules, such as CERN and FRIB, are opening a new frontier in the exploration of atomic nuclei and the violation of the fundamental symmetries of nature. Now, they call them fundamental violations of fundamental symmetries of nature, only because we haven't discovered the true nature of these fundamental symmetries of nature. Because if they can be violated, there is no violation. They're still in line. We just don't know the mechanisms, and in time, we'll discover them. That said, I just want to let you know that you can pick up all of today's articles by typing in !TT in the Twitch chat, because if I stop the show on YouTube, when I'm done doing this show and I end the live stream, the chat goes away. So you won't be able to do commands into ohmTown, which is the bot that facilitates communicating with ohmTown.com. That said, you'll have to go over to Twitch because that's where it's tied in. And so if you type in TT, that'll pull up all of Technology Today's articles. If you hit ! show notes, that'll be all of the show notes for the entire network. But it's the syntax. So for instance, if you want to pull up this week's 4-Wheel Tech articles, you can type in ! FWT. And if you want to get the podcast, you hit ! pod, and that will give you the 7 podcasts that we do, including this one. Non-Sequitur News, Reality Hacker Wanted, WarCrafters, The Continuity Report, Technology Today, and 4-Wheel Tech. Yep, I've got one more show after this one, and we will be done with the news. Sorry. I want to launch 50 shows. All of them are weekly shows. So essentially 50 hours worth of content, all centered around very niche subjects, but not hyper niche. I don't want to focus on just one little niche. It's not dynamic enough for me, and I like change. So, but let's keep on moving. The next article is over in the Mobile channel, and Technology Today typically is a little deeper dive. than your average bearer of general science news. So the cheese of the future, consumers open to animal-free alternatives. I'm definitely one of these that would enjoy the same flavors of our old school foodstuffs without the use of animals. That would be great. So like bioengineered meat and cheese and whatever, as long as it is still healthy, it's nutrient rich, it's sorry, and something that I can actually make at home. Like I can grow microgreens, so why can't I do that? I can take milk and turn it into cheese. So, let me be able to do that at home as well. Food insecurity is pretty high because more and more of it is being aggregated into mega corporations that don't give one whit about your actual food safety unless impressed upon by government overwatch. You know that because there have been like baby formula industry issues where they've known that they've had bacteria in the system for years and they just weren't caught because there's lack of enough oversight. And the fact that so much is being produced by so few that I think that and I was told back in 2019 that the era of cheap food is over. And we've been haunted by that for the last 5 years, and it's not going anywhere because, well, greed is a powerful drug. So anyway, cheese of the future, consumers open to animal-free alternatives in so-called precision fermentation. Egg and milk proteins are produced with the help of bacteria, yeast, and other fungi. This results in foods such as cheese or milk with a familiar flavor and texture. Supporters hope that this will lead to more sustainable food production as nutrient-rich proteins can be produced using fewer resources. But will consumers accept such products? And I think they will. We need to change society's perception of what is acceptable. A glass of white liquid is milk, right? But you're not allowed to call almond milk anymore because it violates some provenance issue with conventional milk from cows. Same thing with, nuts and other things. You're not allowed to call it milk. It might be like a milk product or something like that. But so Thomas Richter from George August Universitat Göttingen put this article together. It's published at phys.org. And so the study, which was conducted in collaboration with LI Food, oh my goodness, I'm going to completely butcher this name, but Landes Initiative, Erna Hoang Schwarzschaft, and Niedersachsen, and the German Institute of Food Technologies, DIL. Thank you, German Institute of Food Technologies, for untying my tongue. Is based on a representative online survey of about 2,000 participants. The researchers analyzed how various aspects of information affect the acceptance of cheese product produced in this way. They analyzed the potential opportunities and risks of the technology, including its relation to sustainability, impact on agriculture, and product quality. So in general, information has only a minor influence on whether consumers would try or buy these cheese products from precision fermentation. Only the reference to the technological genetic modification of the microorganisms required for the production process leads to a slightly significantly lower willingness to try the product. It's because people think that genetic modification is this horrendous boogeyman, except that the steak that people are eating have been genetically modified through selective processing. We short circuit the natural selection, and we give all kinds of other genetically modified products to cows. It might be wheat, but it's been genetically selected. And people freak out about it being modified, but humans manipulating natural selection to get bigger cows, bigger chickens, bigger whatever, bigger crop, etc. All of it is genetic modification. We just don't use it with, a scalpel, Well, I mean, they actually do, but it's not genetic as in like Gattaca, the various elements of the genetic structure. But yes, there are other things that are being fed to the animals that have been genetically modified. So we've been consuming genetically modified food for decades, hundreds of years. We've just been modifying it in different subtle ways and not calling it GMO. So the situation is different when consumers are informed about possible risks. For example, that farmers could lose their source of income due to the new technology, or the large companies could exert too much power over the market. That's why I want, if this is a reality, I want the mechanism so that people at home can make this cheese or grow this product. But bioreactors and the possibility of bacteria, et cetera, it's a different animal. It's one of the reasons why you're supposedly not allowed to but distill at home, is the methanol byproduct and bad esters that are promoted through distillation. So the government says, we'll protect you by not allowing you, but it's really industry regulatory capture and protectionism for the money. And taxes and stuff like that. I'm willing to pay the taxes and the fees to distill at home, but you're not allowed to until individual states get over this BS problem of distillation. And that's the same thing with producing food at home that requires scientific equipment like a bioreactor. But it's definitely doable, and people do it all the time in labs. With education, but it can be dumbed down. So essentially what's going on is the only time people are really worried about it is when they are informed that farmers are going to lose their industry if this goes in a different direction than the current natural way. Because this is natural as well. It just happens to be produced in a bioreactor. I have no problem with this. I want to eliminate food insecurity, and I want the world to get to a point where small communities can have their own vertical farms and bioreactors growing things like cheese and other products, all subsidized by the local community, and the local community picks it up at a store, and there's no animals that are harmed in the process. There may be samples that are taken from animals, but that gets amplified by, natural processes, but scientifically driven. Anyway, pretty neat article. Go and check it out. The next article is over in Technology Today. Redefining Consciousness. Scientists discover what small regions of the brain can take micronaps while the rest of the brain is awake. And I'm doing it now, and so are you. The study broadly reveals how fast brain waves previously overlooked establish fundamental patterns of sleep and wakefulness, and scientists have developed new methods to analyze this data. University of California, Santa Cruz put the article together, and it's published over at SciTech Daily. The study broadly reveals how fast brain waves previously overlooked establish fundamental patterns of sleep and wakefulness. And sleep and awake, they're totally distinct states of being that define the boundaries of our daily lives. For years, scientists have measured the difference between these instinctual brain processes by observing brain waves, with sleep characteristic defined by slow, long-lasting waves measured in tenths of seconds that travel across the whole brain. For the first time, scientists have found that sleep can be detected by patterns of neuronal activity just milliseconds long, 1,000 times shorter than a second, revealing a new way to study and understand the basic brainwave pattern that governs consciousness. They also show that the small regions of the brain can momentarily flicker awake while the rest of the brain remains asleep, and vice versa, from wake to sleep. These findings described in a new study published in the journal Nature Neuroscience are from a collaboration between laboratories of Assistant Professor of Biology Keith Hengen at Washington University in St. Louis and Distinguished Professor of Biomolecular Engineering David Hostler at UC Santa Cruz. And the research was carried out by PhD students David Parks, UCSC, and Aidan Schneider at WashU. Pretty cool. So I'm really into this. You can actually buy ECG or EEG headsets. You put them on and it measures, depending on the number of electrodes, somewhere between like 4 to 11, 22. They're usually symmetrical. And so you can actually monitor brain waves. It's quite amazing technology. And I'm considering getting one because I'm curious about it, but there is a very expensive subscription that's tied to it, which I think is just the worst for armchair scientists. Anyway, yeah, that's the nuts and bolts of this. They say this much input created petabytes, which are 1 million times larger than a gigabyte of data. David Parks led the effort to feed the raw data into an artificial neural network, which can find highly complex patterns to differentiate sleep and wake data and find patterns that human observation may have missed. No, guaranteed have missed. We don't know what we are looking for until we discover it. We just take a stab in the dark and go, oh yeah, look, we hit something. And I admire that. That's fundamental research, and that changes the dynamic of human understanding. So on with the show. They say because of artificial neural networks are fundamentally a black box and don't report back on what it learns, Parks began stripping away layers of temporal and spatial information to try to understand what patterns the model could be learning from. Eventually, they got down to the point where they were looking at chunks of brain data just a millisecond long and at that highest frequencies of brain voltage fluctuations. Quote, we'd taken all of the information that neuroscience has used to understand, define, and analyze sleep for the last century, and we asked, can the model still learn under these conditions? This allowed us to look into signals we haven't understood before. And this kind of research is what I want to leverage when I do my research into your inner monologue, your inner voice. Some people are acutely aware of it. Like I am acutely aware of my inner monologue. When I read something, I hear it in my head. I don't mouth it, and I don't physically hear it like through my ears, but in my mind, I hear my voice. And depending on what it is, if I know the person, or I want to give it a different personality, I can say it in my head as if it comes from a different person, with a voice, not just reading the data and saying it to myself in my mind's eye. It's like imagination, except that it's the voice saying it. I know it sounds surreal, but it is called your inner monologue, and some people have it and others don't. And I've actually talked about this in other channels. Other streamers have talked about it subsequently. And it's a lot of fun to see a channel explode with conversation because they say, wait. The voice that I hear in my head isn't something that everybody does. Yeah, correct. Somewhere around 50% of us have that inner monologue. And it acts as a conscience saying yay or nay to things. While other people seemingly have their they have an understanding of right and wrong, but it isn't really a voice saying, hey, if you put your hand on that hot plate, you're going to burn your hand. But a lot of people actually go through that process. Like, God, I wonder if that hot plate is hot. And it's a conversation. So quite fascinating. And I've found that through conversing with people that, and it's anecdotal, that most of the creatives have an inner monologue, while most of the engineers that I've spoken to don't have an inner monologue. But it depends on what they do. So artists and whatnot, musicians and whatnot have an inner monologue, while many, many others don't. All right. So the impact is gaining a deeper understanding of the patterns that occur at high frequencies and flickers between wake and sleep could help researchers better understand neurodevelopmental and neurodegenerative diseases, which are both associated with sleep dysregulation. Both Hostler and Hengen's lab groups are interested in understanding this condition further. And they're also interested in further understanding the phenomenon in cerebral organoid models, bits of brain tissue grown on a laboratory bench. Okay, let's keep going. The next article is over in Technology Today. New AI model can detect cancer clues at lightning speed. I'm going to jump straight on over to the source. University of Gothenburg put this article together, and it involves artificial intelligence, biomarkers, cancer. And this is pretty interesting. I don't know what this gadget is. Oh, it's a mass spec, really. It can detect different structures of sugar molecules called glycans in our cells, and the measures can indicate different forms of cancer in the cells according to the glycans. So is sugar the cause of cancer? So mass spectrometry can be used to measure glycans, which are sugar molecule structures in our cells. These structures can reveal the presence of various types of cancer within the cells. However, the data from the mass spec measurement must be carefully analyzed by humans to work out the structure from the glycan fragmentation. This process can take anywhere from hours to days for each sample and can only be carried out with high confidence by a small number of experts in the world, as it is essentially detective work learned over many years. Thus, a bottleneck in the use of glycan analysis, for example, for cancer detection when there are many samples to be analyzed. This guy looks like the person from Star Trek. Wesley. Oh, I forgot his name. Doggone it. Anyway. So, can find new biomarkers. That's the objective. The training has enabled Candy Crunch to calculate the exact sugar structure in a sample in 90% of cases, says Daniel Bohar, Associate Senior Lecturer in Bioinformatics at the University of Gothenburg. This means that AI model can soon reach the same level of accuracy as the sequencing of other biological markers such as DNA, RNA, or proteins. So they believe that the glycan analysis will become a bigger part of the biological and clinical research now that we have automated the biggest bottleneck, which is the analysis of glycan. Pretty amazing, and it could revolutionize the processing of cancer analysis and be another indicator. If it can actually predict it, then you can get ahead of it. Along with the other article that we've talked about in the past about DNA apoptosis being activated through a mishmash of drugs that have been developed and a technique, maybe we can eliminate it wholesale instead of treating it as either a custom treatment costing hundreds of thousands of dollars, or the barbaric concept of nuclear medicine like chemo and radiation treatment, which basically bombards the body with radioactive material and kills everything, including the good parts, because the objective is to have your body evacuate all of the bad stuff en masse because it's all getting killed. But cells are very resilient. So, all right, the next article is over in Reality Hacker, how NASA is using AI on the Perseverance rover to study Mars rocks. The NASA's Perseverance rover is taking the first steps towards autonomous science investigation on Mars, basically determining what it wants to do and doing it on its own. Georgina Torbett over at digitaltrends.com put the article together. Using Pixels AI to home in on key science, explained Pixels and principal investigator Abigail Allwood of NASA's JPL in a statement. Without it, you'd see a hint of something interesting in the data and then need to rescan the rock to study it more. This lets Pixel reach a conclusion without humans examining the data. So the system works by using the rover's Pixel instrument, which is the planetary instrument for X-ray lithochemistry, a spectrometer that uses light to analyze the rock, what rocks are made of. The software, called adaptive sampling, looks through pixels data and identifies minerals to be studied in more detail. So it does it while it's there instead of having to send the data. And then basically it increases the amount of time that the rover is actually doing analysis. So the AI system works by taking data from Pixel, then repositioning the instrument, which is mounted on Perseverance arm, using its camera so that it can get close to take a detailed reading without hitting the rock. And then you can see it in action via adorable video, apparently, of the Earth-based model of Pixel. The system will take a reading from one small patch of rock, and if it finds indications of minerals that are interesting, like finding sulfur, it can automatically collect more data on that area and not have to come back or just idle. Do it really quick, and then go, okay, it's not of that great value. We have other science that needs to be done. Okay, let's keep going. We have one more article, or no, I'm sorry, one more article. We have another article that's over in Technology Today. Redefining time and space. Scientists have developed the world's most accurate atomic clock. JILA researchers have created the most precise atomic clock yet, using visible light for time measurement. And the breakthrough could redefine timekeeping standards and unlock new opportunities. The National Institute of Standards and Technology, aka NIST, basically is the one that's been tasked with this kind of a thing in the past, and it will be in the future. It could transform navigation, reveal hidden resources, test fundamental theories like general relativity. So enabling pinpoint navigation in the vast expanse of space and research for new particles. The clock is the latest to transcend mere timekeeping. With their increased precision, this next generation timekeeper could reveal hidden underground mineral deposits and test fundamental theories such as general relativity. So how is it doing it? Trying to find this real quick. Sorry for the dead air. To achieve the new groundbreaking performance, the JILA researchers used a shallower, gentler web of laser light to trap the atoms, compared with previous optical lattice clocks. This significantly reduced the two major sources of error, effects from the laser light that traps the atoms and the atoms bumping into one another when they are packed too tightly. The clock is so precise that it can detect tiny effects predicted by theories such as general relativity, even at the microscopic scale. It's pushing the boundaries of what's possible with timekeeping. This gives me so much fodder for NaNoWriMo. I hope I'm ready for NaNoWriMo this year. It would be great, but I've got a lot of mayoral duties to attend to. It's very frustrating. 1 second. So this will essentially allow for more precise timekeeping. And more precise atomic clocks also enable more accurate navigation and exploration of space. If we want to land a spacecraft on Mars with pinpoint accuracy, we're going to need clocks that are orders of magnitude more precise than we have today in GPS. We actually want to do GPS in space, which would require a more accurate clock. We are moving through space and aka time as well. The new clock is a major step towards making that possible. The same methods used to trap and control the atoms could be used to produce breakthroughs in quantum computing, and so on and so forth. It's actually quite amazing. So this is a clock that is 8 times 10 to the negative 19 systemic uncertainty. That's 8 times 10 to the negative 19th power. So you move that decimal point that way, 19. And that's how precise it is. I'm really curious what the previous clock resolution is, but that's not in this article. Pretty cool. All right, let's keep going. What a bizarre taco-shaped sea creature can teach us about evolution. We talked about this earlier in the week in non-sequitur news, but this article is over at scitechdaily.com, put together by Royal Ontario Museum, and a fossil was found wherein what looks like a a critter, for lack of a lobster with a whole bunch of legs, many legs, is wrapped in a taco. In this case, it actually grabbed onto something, and it looks like a combination between a fish and like a lobster or a crab. Not a crab. Crab doesn't have enough legs. Basically, it looks like a centipede, but in the water. And apparently, it used this taco-like wrapper around itself to fold itself up and hold on to the prey that it had grabbed onto with its legs. And it, like I said, it had many legs. It's kind of creepy. And it has these two little bulbous protrusions on its snoot. I don't know if it's upside down or right side up or what the hell orientation it really is supposed to be. But the study authors were able to identify a pair of large appendages with grasping, jagged edges near its mouth, clearly indicative of mandibles, which are one of the key and distinctive features of the mandibulate group of animals. Basically, it's pushing evolution back like 500 billion years or something like that. Hold on, because we talked about this for a little bit. Hold on. Yeah, so Cambrian fossils record the major divergence of animal groups originating from 500 million years ago. This period saw the evolution of innumerable innovations such as eyes, legs, and shells, and the first diversification of many groups, including the mandibulates, one of the major groups of arthropods, animals with jointed limbs. Mandibulates are an example of evolutionary success, representing over half of all current species on Earth. Today, mandibulates are everywhere, from sea-dwelling crabs to centipedes lurking in the undergrowth. Basically, that's what this thing is, an ocean or a water centipede, or bees flying across meadows, but their beginnings are more humble. During the Cambrian period, the first mandibulates were marine animals, most bearing distinct head shields or carapaces. And that's basically what this is, except that it actually had it had caught something. What's really interesting about this is when I saw this, it reminded me of the fact that somebody used a taco to keep a bird warm, and that made it into the news, but this was not as interesting, I guess, to general news. The next article is over in Greenogram. Heaviest element yet within reach after major breakthrough. Success with a new route to producing super heavy elements paves the way to making the elusive element 120. The article is by Catherine Burzak over at nature.com. And there's this, you'll have to do a search for this, but there is this wall where nobody can actually find any elements within a certain area. And scientists at Lawrence Berkeley National Laboratory in Berkeley, California, announced today that they have, for the first time, used a beam of titanium to make a known super heavy element, livermorium, element 116. After upgrading the lab's equipment, the team plans to use similar techniques to try to produce element 120. The heaviest element that has been made so far is oganesson, element 118, which was first synthesized in 2002. The research is truly groundbreaking, says Hiromitsu Haba, who leads the super heavy element research group at Riken Nishima Center for Accelerator-Based Science in Saitama, Japan. The search for the super heavy element beyond 118 oganesson is proving to be a great challenge, he says. Data from the experiment will greatly improve the accuracy of existing theoretical calculations and will greatly advance mankind toward the discovery of elements 119 and 120. Again, there's this wall in the periodic table and research finding elements in where it goes up heavier and heavier, and then it just drops off where nobody can jump across 119 and 120. So let's see if they actually talk about this kind of a thing in this article. I won't be able to read all of it to you. I do encourage you to follow the article over to Nature through ohmTown, or just do a search for heaviest element yet within reach after major breakthrough. Let's see here. For some reason, they didn't see anything. So scientists have tried to make super heavy elements with beams heavier than calcium-48, including isotopes of titanium and chromium, but for some reason, they didn't see anything. To establish that titanium-50 beams could be used to make super heavy elements, Gates' team made livermorium-290, an isotope that had previously been produced only with calcium beams. The titanium beam is really hard to make, says Gates. Titanium's melting point is almost 1700 degrees C, more than twice calcium's. To make a titanium beam, you have to heat it enough to get ions to evaporate off, and you're putting this a couple of inches from things that have to be cooled to liquid helium temperatures. She says the team used the Berkeley Labs 88-inch cyclotron facility to accelerate the titanium beam and fire it at a target made of plutonium. Yeah, this is pretty interesting stuff, but way beyond my standard area of investigation. But I'm really interested in this because if you do a search for missing elements of the periodic table and Lawrence Livermore Labs, you'll find videos that talk about these missing elements, and I find it particularly fascinating. Okay, we have 2 more articles, and then I'm going to prep for Four-Wheel Tech, which may be a really short show. I'm starting to lose my voice. So, twisters, is it possible to stop a tornado in the real world? No. Just going to call it out right now. No, you can't stop a tornado. It has to dissipate. The hot mess that would ensue would be worse than trying to stop the energy involved in a tornado of any size. Yeah, maybe if it can be called a tornado, then no. But let's see what this article says. Following the recent release of Twisters, fans have been wondering if it's scientifically possible to stop a tornado in real life using methods shown in the movie. This curiosity arises after witnessing the character Kate Carter and Tyler Owens use science to somehow make an EF5 tornado dissipate. Is it possible to stop a real-world tornado using science depicted in Twister? So the article is over at comingsoon.net. Abdul Azim Nashad put the article together. And they say here, is it possible? So can you kill a tornado in the real world using Twister science? And Kevin Kelleher, a tornado consultant for Twister's 1996's Twister, who worked at the National Severe Storms Laboratory in Norman, Oklahoma, for much of his career, highlighted the impracticality of this in real life. In the movie, they use a truckload of chemicals to neutralize the tornado. She then drives the truck to a nearby town. Carter then releases those chemicals into the tornado in a timed manner, leveling with the town. This ends up neutralizing the tornado and causing it to dissipate. Unfortunately, the method that they use to stop a tornado is practically impossible. It would require, it says here, he revealed that it would require at least 22,000 tons of chemicals to dissipate a tornado like Kate did. I think way more than that. Additionally, he mentioned that 22,000 tons of chemicals would not easily fit inside the back of a pickup truck. He then concluded by saying what he saw in the film showed was simply science fiction. Yeah. In fact, the hot mess that would be created by trying to dissipate that all of those chemicals would be released into the cloud, but not all of the chemicals. And I think it's way beyond 22,000 tons. But it would basically act like sandpaper. The chemicals, the particles, everything that's involved in it would just be, it wouldn't evenly and perfectly absorb the moisture, drop it out of suspension, slow down the energy, and dissipate the structure of the clouds all perfectly. It would basically be whipped around and thrown away from the central core of the tornado, which is the hot and cold air transfer of energy. Because once it gets swirling, you see entire houses just picked up, brick buildings and everything just thrown everywhere. The only thing that survives a tornado would be a contiguous 3D print of a cement building. that's built to not have things like roof ties holding down the ceiling and stuff like that. Once a roof is pulled off because of the wind basically grabs the roof line and pulls it away, the walls just fall over because we build really dumb structures in Tornado Alley. Anyway, and hurricane force winds do the same thing. So we need to change what we accept as a living, as a dwelling. But we think that it's cheaper to build stick and nail structures. So anyway, I mean, don't the Three Little Pigs tell us anything, for crying out loud? You have to build a really strong structure. That's basically the motto of the Three Little Pigs, right? The wolf is actually a tornado. It's an analogy for a tornado. Okay, well, anyway, the next article is over in Technology Today. This is the last article for today's Technology Today. It's a lot of technologies in today's. Engineers develop a recipe for zero-emission fuel, soda cans, seawater, and caffeine. A sustainable source for clean energy may lie in old soda cans and seawater. MIT engineers have found out that aluminum in soda cans is exposed in its pure form and mixed with seawater. The solution bubbles up and naturally produces hydrogen, a gas that can be subsequently used to power an engine or a fuel cell without generating carbon emissions. What's more, the simple reaction can be sped up by adding a common stimulant, caffeine. I think this is brilliant. Jennifer Chu over at Massachusetts Institute of Technology put the article together, and it's published at techexplore.com. In a study appearing today, which is actually July 25th. This is a weekly show, so our articles cover from Sunday night to Saturday morning. This show is, let's just call it Saturday or Sunday show. Anyway, the study appearing today in the journal Cell Reports Physical Science, the researchers show that they can produce hydrogen gas by dropping pre-treated pebble-sized aluminum pellets into a beaker of filtered seawater, and the aluminum is pre-treated with a rare metal alloy that effectively scrubs aluminum into a pure form that can react with the seawater to generate hydrogen. The salt ions in the seawater can then in turn attract and recover the alloy, which can be reused to generate more hydrogen in a sustainable cycle, basically a catalyst. So the team found that the reaction between aluminum and seawater successfully produces hydrogen gas, though slowly. On a lark, they tossed in a mix of some coffee grounds and found, to their surprise, that the reaction picked up its pace. That is some wild, spontaneous lark. In the end, the team discovered that a low concentration of imatazole, an active ingredient in caffeine, is enough to significantly speed up the reaction, producing the same amount of hydrogen in just 5 minutes compared to 2 hours without the added stimulant. So I wonder if they find something that is more stimulant than imidazole. The researchers are developing a small reactor that could run on a marine vessel or underwater vehicle. The vessel would hold a supply of aluminum pellets recycled from old soda cans and other aluminum, along with a small amount of gallium, indium, and caffeine. These ingredients would be periodically funneled into the reactor, along with some of the surrounding seawater, to produce hydrogen on demand. The hydrogen would then fuel an onboard engine to drive a motor and generate electricity to power the ship. Pretty damn amazing. Yep. So why did they do this? Don't know. The MIT team, led by Hart, is developing efficient and sustainable methods to produce hydrogen gas, which is seen as a green energy source that could power engines and fuel cells without generating climate warming emissions. Yep. Sounds good to me. It says the one drawback to fueling engines with hydrogen is that some designs would require the gas to be carried on board like traditional gasoline in a tank, a risky setup. Given hydrogen's volatile potential, Hart and his team have instead looked for ways to power vehicles with hydrogen without having to constantly transport the gas itself. But at any time, see, we have the same problem. The energy in hydrogen is much more volatile than the energy in gasoline. The fumes are the problem with gasoline. Gasoline itself would put a match out, but the fumes would light by the time you get your the flame into the gasoline. And such is the same with hydrogen. It's a gas. When compressed into a liquid under pressure, then it has to be released as a gas, and therein lies the problem. But we have propane is the same problem. Gasoline is the same problem. We find a way to make it work. And I certainly hope that it can produce enough hydrogen to power an engine. I would rather have hybrid engines or hybrid vehicles powered by hydrogen, charging up an electric motor and battery system so that I never have to pull over to get gas. I'm tired of using gas. And electric vehicles are dense because it's this massive weight, always loses its effectiveness, and ultimately dies on the side of the road because you can't get to a charging station where it takes hours to get to 100%, even in a battery that after a year has lost 20% of its capabilities. Not a year. I can't remember the total amount. It's like every year it loses 2% or something like that. So after 10 years, it's lost 20% of its capabilities to hold a charge. So its 100% is now 80%. Anyway, hot mess. That's what it is. So there's a lot more to this article. I encourage you to go over and check it out. But the nuts and bolts are that engineers have developed a way to use pure aluminum, seawater, and caffeine to create hydrogen. And that's it for technology today. Yay! I'm going to basically, you know what I haven't been doing? I haven't been powering up our hydrogen machine to bring us back to the front page of Technology Today. Go there, sign up, follow us over on YouTube and on Twitch. That would be awesome. And I will see you either later. I need to take a little break. And tomorrow, there will be no show, but all of these will be available for you to get the show notes, follow them, and go over to YouTube, follow us there, like, subscribe, leave a comment, tell a friend, download the podcast. Go over to the Patreon, follow us there. There's a Discord for ohmTown. It's all in the show notes, folks. And I'll see you later. Time to power up my hydrogen-powered time